Good day, everyone. You are welcome to Anselmigwe Educational Consultancy. Today, our discussion will be on electromagnetic waves. An electromagnetic wave is a wave generated as a result of coming in contact of electric field and magnetic field at angle 90. So this establishes a wave known as electromagnetic wave. Do you know what keeps your fan rotating? The fan blade. It is not only the electricity. Without the magnet inside the fan, there will be no motion. Meanwhile, there is an interaction between the electricity generated and the magnetic field inside the fan, and that produces a momentum that keeps the fan blade rotating. This is an example of electromagnetic induction. So electromagnetic wave has to do with two fields, electric field and magnetic field. So this is the artificially manufactured electromagnetic interaction. But naturally, electromagnetic field covers a large portion of the Earth's surface. And each spectra has its unique application, size of wavelength, and approximate scale. To a layman, the scale, the size of the wavelength, and the kind of objects or humans that you can match the size with. We are going to classify this electromagnetic wave according to the spectra that they are made up of. These spectra are the distinct portions of the wave. The first portion has highest wavelength, but least penetrating power and energy. And the last portion has the least wavelength, but highest penetrating power. So we are starting from the first portion, which is radio wave. Radio wave has the approximate wavelength of 10 raised to power 3 meters, approximately 1,000 meters. You know how the extent 1,000 is. That is the extent the wavelength can go. You know what is wavelength? From the crest, one crest to another, or one trough to another of the wave. Approximately 1,000 meters. And the approximate scale, you can use houses, buildings, and human beings. These things I mentioned now can fit into this wavelength. You know, the wavelength of radio wave can cover buildings and human beings as long as it is. That is the approximate scale. The application. Radio wave is applied in radio and television broadcast. It is also applied in mobile phone. Let me use, for instance, this mobile phone you see can see another mobile phone without using visible lights. As our eyes pick the visible light and use it to see objects as they are. That is how mobile phones detect other mobile phones by seeing into the radio wave. And that is why you can communicate with someone in another continent using your mobile phone, because mobile phones are fashioned in a way that they use the radio wave to detect other mobile phones. So that is the application of radio wave. The next is microwave. Microwave has a wavelength that is less than that of radio wave. The wavelength of microwave is approximately 10 raised to power minus 2. That is about 0.01 meter, approximately 1 cm. So, microwave, that is the extent of the radio wave. It can be likened to the size of a small butterfly, you know. So, that is how the radio wave, the microwave, the wavelength, that is the extent of the wavelength, you know. What is the application? Microwave, due to its ability to generate heat, is applied in microwave oven. Microwave is applied in cooking. Yeah. It is also applied in radar. You know what is radar now? Yeah, the picture is here. Radar. It's also applied in telephone, etc. So that is microwave. The next spectrum of the electromagnetic waves is infrared, IR. Infrared has a shorter wavelength than that of the microwave. It has a shorter wavelength. And guess the size of the wavelength. The tip of the needle is the size of the wavelength. That is to tell you how powerful it can generate energy. The penetrating power is higher. Consider this, using this and using a needle, pressing this on somebody's skin and using a needle to press into the same skin. You will see that the needle will penetrate. This one has an infinitesimally negligible penetrating power. That is how to compare the infrared with microwave and even radio wave. So infrared can penetrate through matter, certain matter, depending on the thickness. So because the wavelength is smaller, as tiny as the tip of the needle, and the penetrating power is higher, and the energy is also higher. Application of infrared is applied in remote. The remote you use with your television works under the principle of infrared radiation. So that remote detects the part of the television through the infrared light. The next is visible light. That is a light we can see. Other parts of the light or electromagnetic spectrum are invisible to the human eye. It is only visible light that is visible to the human eye. And you can see the human eye uses it. Not only human eye, animal eye uses it. Detects objects and living colors using the visible light. The size of the wavelength of the visible light is like that of protozoa. You see how tinier than the needle. Protozoa. The size of the protozoa or protozoo is the approximate scale of the wavelength of visible light. And that is why visible light can penetrate even thicker objects. The next is ultraviolet, UV. Remember, the visible light is further classified into different wavelengths, 7 wavelengths: red, orange, yellow, green, blue, indigo, and violet. These are different wavelengths of the visible light. And the first wavelength is red, and the electromagnetic spectrum closer to red is infrared. Now the last is the last portion of the visible light is violet, and the electromagnetic spectrum following the violet is ultraviolet. It has a lower wavelength but higher penetrating power and energy than that of visible light. The approximate size of the wavelength of the infrared is molecules. You see how tiny molecules are? That is atoms joining together, or even monatomic molecules like that of group 18 elements. So the size of molecule is a scale for the size of the wavelength of the ultraviolet. And what is it used for? As visible light is used for human or animal vision, the ultraviolet is applied in fluorescent bulbs. It is naturally applied in photosynthesis because it is the UV portion of the white light from the sun that is responsible for light phase of photosynthesis, splitting of water and so on and so forth. Without the UV portion of that light that comes from the sun, photosynthesis wouldn't be possible. The next is X-ray. That is the penultimate. X-ray has a tinier wavelength, and the wavelength is likened to the size of an atom. X-ray is applied in devices that are used to snap the internal structure of the body, like the bone, the muscles, the organs, internal organs. And it is also applied in industry to trace leakages. It is used to trace leakages in pipes that carry petroleum. There are microscopic leakages that you can use X-ray to detect before it becomes disastrous. So that is what X-ray is used for. Finally, the gamma ray. This is the most dangerous because it has the highest penetrating power and the highest energy, but the least wavelength. The scale of the wavelength is likened to the nucleus of the atom. You see how small it is, and it is used to destroy cancer cells in the hospital. Yeah, that is what it is used for. you can see that all the portions of the electromagnetic spectrum are important and they have their uses. So kudos to the scientists that discovered this spectrum, electromagnetic spectrum. Kudos to them, because our everyday life today is being influenced by the applications of their discovery. If you found this video useful, please share it. Comment if possible, and subscribe to my YouTube channel, Ansel Enigwe Educational Consultants.